Okay, so I'm reassessing standards 10.4 here. The first question asks us for the moment of inertia of the combined system. So they give us IO, and then for the stick we would just use ml squared. So once you add both of those together, ml squared plus IO is equal to choice D, which is IO plus ml squared. So for number 2, this is basically what we're going to do. Since it asks us to find the acceleration, the angular acceleration, we're going to find the moment of inertia, and then we're going to find the torque of each, and then subtract to get like the total torque, and then use that formula to get the angular acceleration, because torque equals IA. So I found the moment of inertia for both of them, and the moment of inertia formula is ml squared, so 3ml squared plus 1 ml squared, and since it's 2 squared, you'd get 4, so 3 plus 4 is 7. And then to find the torque, it's 3 times the length, because that's the I and the L, times 2 times L, so you'd get equals 1, because 3 minus 2 is 1. And then torque equals I alpha. So then you get 1 mg over 7 ml squared, because if you plug into the formula, that's just what you get. And then you end up getting that 1 lg divided by 7 lg, and you get the l's to cross out because there's 2 in the denominator, so you end up getting 1g over 7l is equal to the angular acceleration. So for number 3, it asks which of the following diagrams is a torque about point 0 equal to the magnitude to the torque about point x, and the diagram above. So we're going to try to look for a picture that has the same length, and for the most part they will do, except for that one. So you could cross out B, and the same downward component force. So if you take C and you solve for that downward component force, you're gonna get that it equals 1, because it's angled at 60 degrees. So you'd have SOHCAHTOA. Cos of 60 is 1/2, and the hypotenuse is 2, so it'd be 1/2 equals the adjacent side, which is what we're trying to solve for because that's down, and 2 times 1 over 2 is just going to be 1, so that's why that's choice C. So for number 4, it says the ant can adhere to the wheel with a force much greater than its own weight, and then it asks us it will be most difficult for the ant to adhere on the wheel as it revolves past like which point. So the answer is going to be C, E, the 3, because there's going to be a greater force because you have the sum of these forces as opposed to 1 where they're pointing in 2 different directions, so you'd end up like subtracting to get that force. So that's why it's C. So for number 5, it asks what's the magnitude of the minimum adhesion force necessary for the ant to stay on the flywheel. So you'd automatically know it's D, because there's two forces. It's not just mg because there's going to be a normal force too. So it's mg plus that, and the normal force is a centripetal force, so it's a weird or whatever. So that's why you can automatically cross out C, because they're adding. So yeah. For number 6, it says the turntable that is initially at rest is set in motion with a constant angular acceleration. What is the angular velocity of the turntable after it has made one complete revolution? I got choice C because I used the formula w squared equals 0 plus 2 alpha times 2 pi, and when you multiply, because like this was the displacement and the displacement is 2 pi because that's how much it goes in like a circle. A revolution is 2 pi, so 2 times 2 is 4, so it's 4 alpha pi, and it's w squared, so you take the square root. So that's how I got choice C. For number 7, it asks for what's the average net torque on the wheel during this time interval. So torque is going to be equal to I alpha, and we know that A, the acceleration, you can find that doing the final velocity divided by time. So the final velocity divided by time is here. All we're missing is an I, so that's how you got choice D. Okay, so for question number 12, what is the average power? Okay, so power is going to equal the change in energy over the change in time, and we know that the kinetic energy formula will be used for this because it ends up going from not moving to moving. So that formula is 1/2 IV squared, and or like W. Whoops. 1/2 IW squared. So it would be choice B because 1/2 W squared is n divided by T. So number 9, it asks which of the following equations best describes a pulley's rotational motion during the block's acceleration during the time the block accelerate. Whoops. So I got A for this because this is what I did. So I solved for the acceleration first, and gravity is causing M2 to accelerate, and when M2 moves, that's gonna cause M1 to move sideways. So Fg is equal to mg, or Fg is equal to m2g. F equals ma, and because gravity is causing the block to accelerate, so you do m2g equals m1 plus m2 divided by m1 plus m2, because those are the masses in the problem, and you end up getting that A equals m2g divided by m1 plus m2, and you want to convert that to angular, so you do A divided by R, and when you do that, you get that it equals m2g divided by R m1 m2, and then you're going to want to find the force perpendicular to the radius for the pulley, and that is Fg and T2 because they're pointing downwards. So T2 is going to equal to the sum. Okay, so first we can find T2 by setting equal all the forces to like MA, because that's a net force formula. So since like the pulley is being like, this is going this way, it's gonna pull it clockwise, and since M1's pulling it that way, it's gonna be counterclockwise, so you gotta make sure there's a negative sign. There's a negative. So negative T2 plus Fg is gonna equal to MA, because those are the forces acting on the pulley, like the torque. And so, because those are the forces acting on it. Okay, so negative T2 plus Mg is going to equal to M times M2 over G divided by M1 plus M2, and that's what we solved for here earlier. So you're going to subtract Mg, and then you end up just getting that T2 equals negative M2 M2G divided by M1 plus M2 plus Mg. So yay, we have T2, and now we can do that for T1. We can solve for T1 by using MA2, the same formula. So T1 is going to equal M1 times M2G divided by M1 plus M2. And when we subtract those, that's how you're going to get like the overall force. And when you subtract those, you end up getting M2G. But the question is, as you can see, it's in I alpha, and that's a thing that equals torque, because torque equals I alpha. So we have to multiply that by radius, because torque is force times radius, well, net force. So that's going to be choice A. So that's exactly why we subtracted the tension 2 from 1. And yeah.